All right, so what do we get for number 1?
F of x equals radical x plus 5 minus 9.
X plus 5 minus 9. Good, good. And number 2?
F of x is negative 4
F of x.
Radical x. Good, good. Yep, we got the reflection, the vertical stretch with the scale factor of 4, so everything that we need. No translations involved, so we wouldn't expect a plus or minus involved. All right, so we talked about square root functions yesterday, and loosely talked about quadratics, but since we did a whole unit on that, we didn't really spend too much time. Today we're going to talk about cubic and cube root functions. Right? They have the same kind of relationship that the quadratic and the square root functions have. So they have an inverse relationship with one another. So you learn about one, you're kind of learning about the other at the same time. All right, so we're going to use the same strategy that we used yesterday to come up with the table of values. That would be to put your calculator in ask mode. Really gotta enunciate that. Okay, because if you go in the table and you see a complete list of x values, it's not in ask mode. All right, so again, the way to do that, because the default setting is to put it in auto. And again, I recommend that you do that. After you do these kind of problems, go back in and put it on auto. Right, so I'll pretend that that's how it was when I picked up the calculator. So you go into the second window, right? So second window, which is table set. Don't worry about table start or anything like that. Under independent, make it say ask. So hit enter on ask. Right. Then when you go into table, it'll have a blank set of, well, it would be a set of values if it wasn't blank. Right. In y equals, I'm going to put my two functions in. This time it's x cubed and the cube root of x. So x cubed. The cube root, you can get that in the math menu. We talked about that yesterday. So math, option 4. Or math and the fourth option. We like that better. Somebody said yesterday that for some of the calculators, it's also in the alpha window menu. So the same place you get absolute values. Some of the older calculators, it doesn't have it there. But if you have one of the newer calculators, if you hit alpha window, it should be option 6. So if you like that menu better. Right, so you have your equations in, we go to the table. Again, it's blank because I haven't typed in any values. So I'm going to type in -8, -2, -1, 0, 1, 2, and 8. All right, so we got a variety of different values here. Some are decimals, but most are integer values. So some of them are huge, but we'll put them in anyway. So -512, obviously not graphing that one. -8, -1, 0, 1, 8, and +512. All right, then -2, -1.26, -1, 0, 1, +1.26, for some reason rounded differently, and then +2. All right, so just like yesterday, we're going to graph some of these points, but not all of them. Again, the obvious thing is the -512, not plotting that. But I don't even want to plot -1.26. Right? So I'll plot the reasonable ones like -2, -8. 1, 2, 3, 4, 5, 6, 7. -1, -1, 0, 0, 1, 1, and then 2, 8. All right, put a smooth curve through it, or as smooth as you can make it. you miss a point, just make the point bigger. All right. So then for the inverse function, I'm plotting -8, -2. Then -1, -1, 0, 0, 1, 1, and then 8, 2. All right, so it's the same function, just turned. All right, it's a rotated function. But it does seem to merge a little bit for a period of time there around x equals 0. All right. Now, one thing I alluded to yesterday, but I didn't really talk about it too much, is that if I were to draw the line, and I'll just rough it in here as a dashed line, the line y equals x, you notice, or I did a halfway decent job of drawing the diagram, that one of these graphs should be a reflection over this line of the other one. So you just either turn your page or turn your head, and you'll see that if you were to fold this paper on using this line, that these two graphs would match up with one another. All right, that's a quick visual way of determining whether two functions are inverses or not. All right, and that would work with what we did yesterday too. All right, except we didn't have the entire sideways parabola because it wouldn't be a function. Here you can have the entire sideways cubic function because it would still pass the vertical line test for all of the x values.
When you're plotting the purple line, which numbers do you use?
X against these bad boys,
Okay.
but I ignore the decimals. All right, so a little follow-up question here. Using the tables and graphs, what observations can you make about the relationships between y equals x cubed and y equals the cube root of x? We're looking at graphs that are inverses of one another. So graphs are inverses of each other. And that's a reflection over the line y equals x. All right, there's other observations, but they all kind of go hand in hand with that one. And that is, if I take a coordinate in the y equals x cubed graph, like -2, -8, and switch the x and y values, that would give me a coordinate on the y equals the cube root of x graph. Right? So if I take the -2, -8, and swap them, I get a coordinate that's on the other graph, -8, -2. Right? So observations like that are consistent with the idea of being a reflection over the line y equals x. So I don't think we need to state that separately. Also, the idea that it appears to be some kind of rotation, but that's covered in this transformation of a reflection, right? So we know that it's the original graph transformed in some way. That's covered by the idea that it's a reflection, so we don't have to state that further. The idea that they're inverses and that it's a reflection gets the job done. Okay.